See this guy in the lab.
Okay, go.
Okay, so like I was saying, with each new risk, each new plant, this risk grows, and we've all heard of all the illnesses that can come along with it, like hair loss, cancer, altering DNA, goiter, psychological effects, and so on. And I want you to know that it's not only high contamination levels needed for this. Repeated exposure and the proximity to our organs, so I mean like if we're ingesting it, the different ways it comes in contact with our body is important. And I want you to keep this in mind as I go through some concerns I have with the reactor process. So just to start off with a very small issue, it's the coolant, I mean. On a daily basis, billions of gallons of water are being used as coolant, some of which is recycled and put back into our water. And I raised two concerns: sustainability of this process, so much water, and the risk of the recycling process going wrong. The way we attain this radioactive material is also a little worrisome for me. The biggest one is the release of radon gas from the rocks being mined, and that's poisonous gas for us. Then transportation of this material. As soon as I hear transportation with nuclear material, it sort of worries me, because we know every day accidents happen and kill people, but now with like enriched uranium in the passenger seat, people not even involved in the accident can be harmed. Much greater issue is the fuel. The half-life is very long on substances involved. Some are around billions of years, and we need to know they've got to go through 10 half-lives to be considered safe. And this gets compounded more and more because we know there's lots of fuel cells in these reactors, and as they get more and more, they just put them into a pool of water, and with more and more, the charge density goes up in that pool, and sooner or later, I feel like it's going to get to the density of a reactor's core. So what are we supposed to do with this? Are we just supposed to expand these pools more and more and waste more land? Or what's the deal with these? There's no long-term plan. And I already say, like, we've already got a waste problem in our country, and now we want to make it nuclear, and now we want to make it radioactive, and that's going to be a big concern. And we know reprocessing can't be relied on, as my partner's going to tell us about. And then there's just all the things about how unpredictable there are, but we're going to run out of time, so I'm going to pass it on.
Alright, so the thing with nuclear power plants is that we're mining uranium, we're preparing and cooking our meal, and then we enjoy our meal. So now what's left is washing the dishes, right? But how? So now the nuclear industry sees reprocessing plants to be a solution to degenerate waste. So now this is a serious fallacy. In the reprocessing plant, spent fuel is chemically treated to separate into fractions consisting on fission uranium, newly formed plutonium, fission products, and actinides. So now this is spread over large volumes of liquids and solids. And all these gaseous fission products, such as tritium and carbon-14 radioactive noble gases, are released into the air. So now, just to give you an example, a reprocessing plant at French La Hague discharges more radioactive krypton-85 in 1 year than was released by more than 500 atomic weapons tests detonated worldwide over the course of decades. So now, just imagine the pollution. Also, just to point out, complete separation of uranium, plutonium, and other highly radioactive is practically impossible. So a significant fraction of the radionuclides are discharged from the plant with wastewater into the sea. So now, just to give another example, the French La Hague discharges 100 million liters of liquid waste in the English Channel each year, which pollutes the ocean all the way to the Arctic, and 11 Western European countries have asked them to stop reprocessing. So not only does reprocessing pose a threat in terms of pollution, it also introduces a new level of terror. Reprocessing is how governments go about creating nuclear bombs, because plutonium is one of the primary ingredients to nuclear weapons. So now, just to give you an example, only 6.1 kilogram of plutonium was used in the Nagasaki bomb to render a...
30 seconds.
To render a... Okay, just to sum up, we have a complex technology. It's done or what?
10 seconds.
Alright, so we have a complex technology that is practically impossible to be called inherently safe, and Yeah.
Also, alternative energy is a lot cheaper than nuclear energy.
Matt, what's up?
Thumbs up. Can anyone? Okay, let's start with the second team. As most of you already know, nuclear energy utilizes the energy stored in atom in a high-density energy elements. 1 kilogram of fossil fuels can produce 3 to 6 kilowatts per hour, whereas uranium can produce 60,000 kilowatts per hour. No energy is 100% clean, but the great advantage of nuclear energy is that it emits little to no greenhouse gas. According to the Nuclear Energy Institute, this energy relieves Earth from 2 billion metric tons of CO2 per year. Plants can be set up almost anywhere as long as there is a source of water to cool the vapor pressure down. This means that a country doesn't need to be necessarily rich in any type of natural resources to generate its electricity efficiently. There are more than 400 operating nuclear plants around the world, which accounts for 13% of the world's total energy. As Kim will explain to you later, not every country has feasible solutions to account for this loss. Nuclear energy is still at its beginning of development. Current new reactor prototypes are expected to utilize even more efficiently the energy stored in radioactive elements, produce less nuclear waste, and use a more variety of elements. An example would be the thorium reactor, which functions without the use of water pressure, which is the #1 leading cause of accident people are most afraid of. It is also expected to produce 3.5 million kilowatts per hour per kilogram of thorium. The point that I'm trying to make here is that it is yet too early to give up on such promising energy source.
Alright, so some of you might be thinking, why not invest in other green energies instead of investing in nuclear? In the US, more than about 20% of the electricity generated is generated using nuclear energy, while only 5% of the electricity generated is coming from wind and solar powers. So why is that? Why would that clearly proves that nuclear energy is more reliable? Because the thing about wind energy is that the turbines can only generate energy when the wind is between a certain range of wind speeds. And solar energy only works if the sun is shining strong enough, right? And the thing about this is we have to use the electricity right away, whereas uranium, it sits there, it's stored energy, you can use it later on. So in France, and if we decided to shut down nuclear energy, a lot of people have a lot to lose. While Ivy stated that only 13% of the world's energy is generated by nuclear energy, in countries like France, for example, who cannot properly harness onshore wind energy and solar energy, more than 75% of their energy is generated using nuclear energy. If we were to shut down nuclear technologies, France would stand to lose a lot of investment, as well as they would have to find a new source of energy. Another thing is that a lot of developing countries are growing in population, but also growing in energy demands. So, in order to save space, nuclear energy is a very good alternative, because a nuclear plant which generates 1,000 megawatts would only require a surface area of 1 to 4 kilometers square, whereas a plant which generates the same energy but using wind power requires 5 times that area and 12 times that area, and a solar plant which generates 1,000 megawatts as well would require 5 times that energy, 5 times that area. So as you can see, it's very space efficient. With more than 10 European countries already using nuclear energy to provide at least a third of their electricity, why should we stop investing in a technology that already serves so many so well? Well, some of us. Okay. Okay. Well, okay. Okay. So what I just want to note there is that the current energy that we're using is coal, and coal makes up 40% of the electricity generated and 80% of it in China. And the death toll for coal processing is more than 2,000 a year for China, whereas for nuclear energy, only 10 people have died within the last 10 years from nuclear power plants that have happened.